Good evening. We are group number 1. Tonight we are going to discuss the topic of sustainability. The presenters this evening are Josh, Raul, Huang, Justin, Monica, and Aaron. Sustainability is defined as the quality of not being harmful to the environment or depleting natural resources, and thereby supporting long-term ecological balance. We will be discussing things relating to sustainability, such as renewable energy, food conservation, and smart building practices. Kicking off the presentation tonight is Josh with renewable energy. When the topic of sustainable energy is brought up, there are many different types that can come to mind. Here's a list of 6 types of sustainable energy. They are solar, wind, geothermal, ocean, biomass, and hydroelectric. The 2 we're going to cover today are solar energy and wind energy. Solar energy. Solar energy works by capturing the sun's energy and turning it into electricity for your home or business. Our sun is a natural nuclear reactor. It releases tiny packets of energy called photons, which travel the 93 million miles from the sun to the earth in about 8.5 minutes. Every hour, enough photons impact our planet to generate enough solar energy to theoretically satisfy global needs for an entire year. There are many advantages and disadvantages to solar energy. I'll list 3 of the advantages first. They are: once solar panels are installed, there are rarely any additional costs for the next 25 years. Most new solar panels come with at least a 25-year warranty. Some newer inverters also have a 25-year warranty. Solar panels produce no pollution after they have been installed. Solar energy won't run out because the sun will keep on shining. 3 disadvantages are: larger upfront cost. New solar installations can range from approximately $12,000 for a small system to well over $40,000 for a large system. Creating solar panels do create some minor pollution when they are produced, but the effect is offset by the energy they create later with no pollution. You only get solar energy when it is sunny outside. This means you get more solar energy during the summer months and less during the winter months. When it is overcast or raining, you won't get as much solar energy out of your solar panels. How is energy generated in Oregon? According to Oregon.gov from 2014 to 2016, this is how Oregon's electrical energy was generated: 40% from hydroelectric, 31% from coal, 16% from natural gas, 6% from wind, 3% from nuclear power, and many other minimal sources, including solar. Oregon has been working to increase its sustainable energy sources. They've done this by offering tax incentives or rebates for consumers wanting to invest in solar energy. There are also tax rebates offered by the federal government. Here is a slide that shows how solar energy production has increased in Oregon since 1999. As you can see, the largest increases in solar production have come from the utility sector since 2015. The commercial and residential sectors have also kept on growing, but not as fast as the utility sector. A little closer to home, what has PCC done with solar? In 2012, a partnership was created between PCC and Oregon-based public and private entities, including the Energy Trust of Oregon, Solar City, Solar World, and the Oregon Department of Energy. Through this partnership, a 500 kilowatt solar array was installed at PCC's Rock Creek campus. This new solar array was expected to provide at least 60% of the energy used by Building 9. How well have they met that 60% expectation? This is a graph of the energy used by Building 9 in 2019. The red is the energy consumed, and the green is the energy created by the 500 kilowatt solar array. In 2019, the solar array provided approximately 58% of the building's energy use. Overall, from when it was installed in May 2012 to February 2020, the average energy provided by the solar array was 55%. Since its inception, the solar array has produced 4.5 million kilowatt hours of energy. Solar energy is still a growing industry, shows no sign of slowing down, is becoming more affordable with all the incentives as well as the cost to make them going down over time, and is a clean, sustainable energy. Up next is Raul with the topic of wind energy.
What is wind energy? According to windsolaralliance.org, wind energy is the use of wind to provide the mechanical power through wind turbines to turn on electric generators and to do other work like milling and pumping water. Wind energy is a serious and impact component of electrical power generation. And this website talks about how wind energy is a clean source of electricity which keeps electricity rates low and provides a renewable alternative to fossil fuels like coal, oil, and natural gas. Here's a short video on history and use of the wind turbine.
Make electricity. A wind turbine is a device that converts the wind's kinetic energy into electrical energy. Wind turbines are manufactured in a wide range of vertical and horizontal axis types. The smallest turbines are used for applications such as battery charging for auxiliary power for boats or caravans, or to power traffic warning signs. Slightly larger turbines can be used for making contributions to a domestic power supply, while selling unused power back to the utility supplier via the electrical grid. Arrays of large turbines known as wind farms are becoming an increasingly important source of intermittent renewable energy and are used by many countries as part of a strategy to reduce their reliance on fossil fuels. Wind was shown to have the lowest relative greenhouse gas emissions, the least water consumption demands, and the most favourable social economics compared to photovoltaic, hydro, geothermal, coal and gas.
According to www.oregon.gov energy website, in year 2018, Oregon's wind energy industry has developed mainly on the Columbia River Plateau in north central Oregon and eastern Oregon near Milton, Free Water, and North Powder. In 2018, had 3,383 megawatts capacity, 44 operating facilities, one spans Oregon and Washington state line. How wind energy is used these days? According to Clean Energy Ideas, last updated October 18, 2019, here are some ways on how wind energy was used before and how it is used nowadays. Wind energy started being used by civilizations years ago for sailing. They depended on the wind energy to power the ship. They also used wind energy for food production, like windmills used to mill grain. Nowadays, wind energy is also used in many sports like windsurfing and kiteboarding. Wind energy is used to generate electricity. As the turbine blades move with the wind, a generator starts to turn, which produces electricity. Is wind energy good for the environment? As found in U.S. Energy Information Administration, last updated December 4th, 2019, using wind to produce energy has fewer effects on the environment than any other energy source. For example, wind turbines do not release emissions like gas or radiation that could pollute the air or water, with some rare exceptions. They do not require water for cooling. Most importantly, wind turbines reduce the amount of electricity generation from fossil fuels, which results in lower pollution and carbon dioxide emissions, which will stop global warming. According to Clean Energy Ideas website, October 18, 2020, there are some pros and cons of wind energy. Here are the pros of wind energy. Number one, renewable and sustainable means it relies on the sun shining and wind. Number two, it's good for the environment. It does not create pollution. Number three, it does not use fuel. The fuel that uses is wind. Number four, less space. In average, one large turbine has the capacity to generate enough electricity to power 600 U.S. homes. Number five, low operating costs. Number six, Energy independent. This means that anywhere where sun is shining and there is wind. Number 7, wind energy can provide power to remote locations. Here are the cons. Number 1, the wind fluctuates, meaning that the wind doesn't always blow 24/7. Number 2, wind turbines are expensive. Number 3, wind turbines pose a threat to wildlife but minimal. Number 4, wind turbines are noisy. Although there is pros and cons of wind energy and there are some disadvantages to consider, the wind remains one of the cleanest and most friendly sources of energy available today. And now, here is Hong Pham and Justin Stenberg talking about sustainable food.
Why is sustainable food so important? There's lots of reasons. Biodiversity loss of plant species, interference of nitrogen cycle, food shortage being caused by food waste, and even climate change from the food waste. This still isn't everything it impacts. According to the Washington Post, in an article they made in July of 2018, globally we waste 30% of our food, which accounts for 8% of our total greenhouse emissions. More than 70 billion tons of greenhouse gases could be prevented from being released into the atmosphere by cutting down on food waste. By cutting down on food waste, we can feed more starving people. What are some of the ways we can help combat food waste? Shop smart and purchase more produce from the local shops or farmers markets. Eating your leftovers, keeping track of what you throw away, invest in composting options. You can do a whole lot with the waste we just throw away. When we researched sustainable food, we found that PCC is very big on local and sustainable food. The PCC dining services offer smaller portions as well as offer trayless. The Aussie and composting are food scraps. The kitchen scraps end up being turned into healthy soil for our gardens at Rock Creek and Sylvania. Another interesting thing is that here at the gardens, you can volunteer your time to help with the gardening chores, which allows you to grab whatever produce you wanted that's available from the garden here. The food from the garden is additionally offered to the school and later on given to gleaners. Agriculturally, we have a need for sustainability as well. The normal style of agriculture consists of heavy tillage and chemicals and is destroying our soil ecology while using up our water at an alarming rate. We are becoming more susceptible to drought and rapid deforestation and industrialization, and we are threatening our plant biodiversity. A couple different methods for keeping our agriculture sustainable is to help rotate crops according to the seasons and your region. Proper agroforestry practices where trees and shrubs are growing around your crops. Agroforestry can help control runoff, soil erosion, as well as reducing the loss of soil and water and other nutrients. Cover crops are plants that are planted not to harvest, but to enrich the quality of the soil and protect it from disease. Locally, we can refer to OSALT when looking for the best agriculture practices. OSALT stands for Oregon Sustainable Agriculture Land Trust. OSALT is the only statewide land trust in Oregon with the mission for preserving land for sustainable agriculture and then educating the local community about the research that they have done on donated land. PCC and OSALT are just a few Oregon groups trying to take sustainability to the next level, and it really shows that if you're willing to help just a bit and do your part to educate and raise awareness, others might follow.
How many of you consider where your food comes from and what it took to get in your plate every day? The food system today is destroying the environment upon which the future food production depends. It contributes to some 20–30% of anthropogenic greenhouse gas emissions. It's the leading cause of deforestation, land use change, and biodiversity loss account for 70% of all human water use and is the major source of water pollution. Although the whole food chain from farming to the transport, cooking, and waste disposal contribute to this problem is the agriculture state where the greatest impact occurs.
In Oregon, local foods are accessible at over 160 farmer markets located across the state. Farmer markets do not provide the only way to purchase local food. It is also possible to visit the farmer market and enjoy product directly. One local farmer called the Wholesome Family Farm particularly in a practice called the herd sharing. Herd sharing are characterized by the farm owner caring for the cow owned by individual for or family who simply pick up the commentary provided by the cow whenever it's become available. This type of farm allow people who would not otherwise be able to have locally produced food the opportunity to have it for the environment. What we eat and how it is formed had a tremendous impact on the quality of our environment. Over 25% of Oregon land is used for grow on food, plant, seed, and support the animal we rely on for the food and fiber. The way farmer and rancher manage Oregon agriculture land can significantly impact both positively and negatively the quantity of own water, air, and natural area. Food processing and distribution can also impact on air and water quality through transportation, packing, and manufacturing. Up next is with Aaron and Monica with sustainable building.
Part of sustainability means building green. Building green means it includes materials, for example, bamboo, green roofs, wood, straw bales, and hempcrete. We will take a closer look at green roofs and hempcrete. Green roof benefits. There is an increase in R value, which is the measurement of resistance which controls the current going through the roof. Green roofs also help improve stormwater intake. Instead of water just sliding off the roof and going into the gutter, the green roof allows the water to go into growing the plants instead. This reduces the amount of water going into the streams and rivers. Heat reduction. Large areas that have plenty of pavement tend to have increased surrounding temperatures. Green roofs absorb the heat, therefore lowering the temperature of a building. Having different types of plants on the green roof lowers the carbon emission and carbon dioxide, as well as increases photosynthesis. Disadvantages. The cost of building will take a lot of money due to the addition of plants and installation. Keeping up with the maintenance is also a disadvantage. Having the time and money to take care of your home is also something your home may be vulnerable to. It will add up to 50 to 200 kilograms per meter squared for each section of the roof. Some roofs will need to be remodeled to support the extra weight. For flat roof houses, this may not be needed. Hempcrete. When being made, there is more carbon dioxide being consumed than made. It is made of hemp, which can't be consumed like weed. Hemp is very renewable and easy to access. When made, it is left to dry until the hemp can be soaked in water with lime. This allows the fiber to come out of the plant. Once dried, the herds are harvested to make what they call hempcrete. Disadvantages. Cost. People must pay more to get access to the materials. Builders don't have enough knowledge on how to build with hempcrete. Hemp has only been legal for a few years, which hasn't allowed people to gain experience on how to make it or build with it. The material may rot if it stays wet for a long period of time. Hempcrete can't be used for foundations. When used underground, the hempcrete absorbs water. It is best used above ground. Next is Aaron with the building envelope.
The most important element of a sustainable home is its envelope. A properly designed and installed building envelope is crucial to the lifespan and energy efficiency of a home. What is a building envelope? A building envelope is the physical enclosure of a building that separates the conditioned space from the unconditioned space. In other words, the material separating the outside from the inside. The building envelope's job is to resist and/or reduce four things from passing through the envelope, which are, in order of importance, bulk water, air, water vapor, and thermal. The most important thing we want to keep out of our homes is bulk water like rain. Our first line of defense against bulk water is the siding. Siding works great for shedding bulk water as it runs off the roof and hits the walls, but when wind is introduced, it can drive bulk water in between the seams, where it will sit and slowly rot away the building. How we can reduce this risk is by attaching a water-resistant barrier to the sheathing, which prevents bulk water from touching the sheathing. But this does not prevent the siding from rotting. To solve this, we also need to install a rain screen. A rain screen is a series of vertical strips attached to the exterior walls that the siding is then affixed to, creating an airspace between the siding and the wall. This airflow will allow bulk water that makes it behind the siding to dry. The second biggest threat to a building's performance is the leaking of air. Air is like a highway, and water vapor and heat are like cars riding along its path. Up until recently, we've been designing and building homes so that they quote-unquote breathe, but what they're really doing is leaking. As the heated inside air rises and escapes, it's being replaced by cold, damp air from your crawl space that rodents inhabit, a behavior known as the stack effect. This leads to excessive heating loads and cooling loads, unhealthy air quality, and potential mold inside the wall cavities. Instead of letting your buildings breathe like a frog through its skin, we need to make them as airtight as possible and provide lungs for the intake and exhaust by means of mechanical ventilation. Air sealing isn't a specific material, it's rather a method. Anywhere where a seam, crack, joining of walls and roofs, light fixtures, or electrical boxes, there is a leak. We can seal these with tapes, mastics, caulkings, and spray foams. In theory, if you stop the leakage of air, you can stop the leakage of heat and water vapor as well. We don't live in a vacuum, though, and the complete sealing of air is impossible to achieve in a building. We can get really close, but there will always be a leak somewhere. With this in mind, we must not ignore the next major potential for damage, water vapor. Water vapor is water in its gaseous state. It is invisible and is able to change into liquid state, known as a phase change. Relative humidity describes the amount of water vapor in the air compared to if it were saturated. So if the relative humidity is 50%, there is half as much water vapor in the air as there would be if it were saturated. This matters because warmer air can hold more water vapor than colder air. So warm air with 50% relative humidity has much more water vapor content than cooler air with the same 50% relative humidity. When this warm, humid air from the inside leaks through the walls and comes in contact with the cooler air inside the wall cavity, that cooler air can no longer hold the water vapor, and it goes through a phase change into liquid bulk water. It has hit the dew point. This water is now inside the wall, creating mold on the drywall and sheathing. We can prevent this through vapor barriers and vapor retarders. Vapor barriers like polyethylene completely block water vapor from passing through. These are used in crawl spaces on the exposed ground and under concrete slabs to stop water vapor from coming up. This is not advised to do on the walls because as temperature changes, so does the site at which dew point happens. Instead, we want to use vapor retarders, which reduce the amount of water vapor being allowed to pass. Lastly, we want to think about heat loss and heat gain, more specifically thermal resistance. We want to be comfortable in our homes, stay warm when it's winter and stay cool in the summer. In the past, we achieved this by cranking up large heaters and air conditioning units full blast. This way of conditioning a space didn't resist the heat from leaking to the outside in the winter, nor stop the heat from re-entering the space in the summer, resulting in excessive heating and cooling loads. We now know that we want to add some insulation in our walls, attic, and crawl space to resist heat loss and heat gain. Insulation comes in many forms, and its effectiveness is measured in R value. The higher the R value, the more resistant to heat penetration. For years now, we have been putting insulation inside the wall cavities, but it's actually best to have your insulation on the exterior of the wall. There's a couple of problems with putting insulation inside the walls. First problem is thermal bridging. Insulation can only be put in between each stud, and the R value of insulation is only effective in the spaces it's installed. Studs have an R value as well, but it's so low that it's practically not effective. Studs make up roughly 28% of the wall cavities, leaving only around 70% of actual insulation, and the rest is gaps from things such as electrical boxes. These studs are acting as a bridge for thermal to pass through the walls, known as thermal bridging. Thermal bridging is eliminated when the insulation is on the exterior of the wall because it can run continuously, uninterrupted by the studs. The second problem relates back to water vapor. We want the dew point to happen at the exterior of the home, not inside. As water vapor diffuses through the wall, it is kept at a low relative humidity passing through the insulation. When it hits the sheathing that is exposed to the cooler outside air, there is a chance for the dew point to happen on the inside of the wall cavity. By having insulation on the outside, the sheathing stays warm, preventing the dew point from happening until it reaches the outside where it can be dried out with the rain screen. There's a lot of science happening in our homes that we are starting to recognize. By changing one thing, we could potentially cause another issue if not done with careful consideration. This is why the building envelope is so crucial to the sustainability of a home, for its lifespan potential and its energy use. The topic can get very complex, but has been boiled down to a simple saying: build tight and ventilate right.
Tonight you learned a little bit about 3 areas of sustainability. We went over the benefits of renewable energy, ways to eliminate food waste, and new ways to think about how we build the homes we inhabit. There are many more sustainability topics, far too many to talk about in one presentation. Our goal tonight was to bring to your attention the areas we felt strongest about and to discuss the sustainable solutions that exist today and why they are important. We thank you for your time tonight, and we hope you learned something useful from our presentation. Thank you and good night.